Hello, in this video I am going to show you how I did my exploratory factor analysis. So we have this data set all cleaned and nice, and just head to analysis, go to dimension reduction, factor. Now you're going to drop in there all the factors that all the factors. I already dropped them in here, all the factors that you are using for your study. Then under descriptives, keep the KMO, and extraction, keep it as based on eigenvalue. And then for rotation, Promax. And for options, suppress small coefficients below 0.3. And then run the analysis. Okay. Once you run the analysis, you focus on two things. The total variance explained. All these factors, as you can see here, we have 9. You can tell from here we have 9 latent variables or constructs, and the cumulative percentage that they explain is 72.64. So it's over 50 or 60%. This is a very good sign. So this is the total variance explained by these latent variables is up to 72.64%. This is really an amazing sign. Second, we focus on the pattern matrix if you are using a Promax rather than the component matrix. So over here, what you really need to take a look at is that you know that fit 1 to fit 5 measures one variable, that is, for example, the brand fit. So you want all these guys to load in one factor and one factor only. This means that they all mean one thing, and they so over here we have the brand fit loading. It's the only thing loading in factor 1. So this factor is brand fit. Look at factor 2. You have most of the loadings here on trust. So you have trust 1 all the way to trust 4. You have double loadings here coming from other factors, coming from expert 4 to trust, coming from attractiveness to trust, coming from similarity, coming from parasocial. This means that these questions kind of consistent with the meaning and overlap with the meaning of trust. So I would say that a trust latent variable seems to be very important because you have other questions loading on it or double loading on it. All right, so you have here trust, and these are only double loadings. Now let's take a look at the third one. The third one you have here, this is a stray dog. This is supposed to load over here, but seems like the loading in the info is below 0.3. In this case, because we have a theory, we have put the questions based on a theory and the previous research. We're going to keep it as is in the confirmatory factor analysis unless we will find out that, and I think we most likely going to find out that the loading of it, I will show you in the next video when I do the confirmatory factor analysis, you'll find out that this info 1 will not have a high regression value with its latent variable. Why is that so? Because as you can see, it's loading somewhere else. So you might need to drop this. So this is why I like exploratory factor analysis. I won't get surprised really. I get surprised before I do the CFA. Over here you have double loading, but look, this double loading here with info 5, it is supposed to be here all together with its sisters. And this loading is way much higher than the loading elsewhere. So this is a little bit comforting, but the difference isn't that high. So this means that probably it won't also have a very high regression loading in the CFA. Over here, the loadings are good. They are entertainment value. There's no double loading here. There's no double loading here. And these are all attractiveness. They are all nice except for this one. Attractiveness 4 is loading higher on trustworthiness rather than in attractiveness itself. So I like to keep note of this kind of notes. Anna, I put for you here all always we can come back to the theoretical framework, then to the we don't need these here. We have another document that has all these sources, but we also need this document to go back to the definitions, right? Sometimes we need to review the definitions. So I'm going to just make it a little bit shorter in our shared notes. Okay, so now once you lined up your data nicely here, this is how I got to the exploratory factor analysis with SPSS. So I'm going to write here SPSS. And basically this is the results. I put it on Excel, and then I highlighted the problematic kind of, not problematic, but the kind of observations that I just explained right now. So this has 2 double loadings. So even if you decide to get rid of this, it's all right. This is because you have 3 other questions here. So you can get rid of it. However, I would say that this has loading 0.8 in its own factor under its own roof. So it's kind of good. Over here, I put a list summary for us so that we can always come back to it when we're doing confirmatory factor analysis and we see some strange observations, or we think by troubleshooting we might get better results if we drop one question. So which question shall we drop? Then we can get rid of the questions that been already showing some distinguished, not in a good way, but in a very odd way, behavior. They showed them some odd behavior. All right, but because we have created this whole thing is based on an already existing priori theory, then we don't have to drop anything for the CFA unless it is showing a bad signs or giving us a very bad model fit. We're going to talk about this later. So you know why I'm doing this? I'm doing this just in case in the future we're not getting a very good model fit. In this case, we might, one way to improve the model fit is probably get rid of the very low loadings in the CFA. So this would be a good candidate to drop, and also this and these 2. All right, so what I need from you, I want to also show you how I did what we call it the Cronbach alpha, or the reliability test, or internal consistency. And this is the definition here of internal consistency. One thing that I haven't mentioned here, it's not mentioned here because it is kind of related to whatever study you'd like to refer to. But in general, the threshold, the acceptable threshold for Cronbach alpha is 0.7. You are so happy if you got 0.7. Sometimes 0.6 is acceptable if you don't have a theory and your sample size is not that big, that huge, but you have a very solid literature. Well, good luck. I am in this. You know what? With my other data set, Anna, I had a beautiful pattern matrix, a beautiful clean one. Honestly, this one looks messy compared to the one that I had, but one of my variables didn't have a nice reliability. It has a reliability of 0.69, so it's on the edge. So researchers or editors, they like to see the 0.7. So how do we get the reliability test? You go down to the scale, reliability analysis, and you put, for example, all the factors related to purchase intention, and please make sure that you label it, because if you don't label it, you won't know these results belong to what. So over here, you know it's belonging to purchase intention. If you don't have anything here in the label, it will be blank, so you won't know which variable is this. And this is 0.87. How beautiful. Take a look at the other ones, Anna. I have it all done actually for you, but I'm going to show you. I got so impressed with trustworthiness. You know why? Because I had two very problematic in my head. The similarity, for example. Remember, there are here when we were talking about the double loadings, most of them were double loadings in here. Similarity, trustworthiness here wasn't really nice clean cut. You have so many reds. And also here you have so many reds under similarity. So let's take a look at similarity, and let's take a look at trustworthiness. Look at this beauty, 0.84. Oh my, these are awesome numbers. And trust me, you are very lucky to have such numbers. These numbers, the Cronbach alpha, is more important, to tell you truly, than the just the neat, getting a neat pattern matrix. Yeah. Okay, look at this. This had made me feel more and more comfortable. Look, 0.940. However, this is 0.940 with what it is, how we design the research, right? So you don't get confused that this, you got the 0.90 because you have more factors loading into it. These factors, we didn't add them to the dialog box. We only added 1 to 4, right? Because sometimes my students might get a bit confused and say, of course, because you have more than 4. You have 4, 5, 6, 7, 8, 9. No. You have seen that I only added 1 to 4, the trust only once. Okay, good. So now I only would like you to do the following. I would like you to take a look here. Over here, this is why I like to work with OneNote. OneNote, I can upload a PDF file on my OneDrive, and then you can open the PDF file and take a look at it, or you can reproduce the results. I would like you to reproduce the results if you would like to get proper training. In fact, you are the one who's supposed to do all this and show me the results, but it's okay. So also look at the KMO here. It is significant, so that's also a very good sign, and the value is very high. I think this is a good sign. And also I'm going to write also about this test for you over here. So let me just write the title here so I won't forget. Okay, so I'm going to write about the KMO and the Bartlett's test for you, so that you know the threshold and what we're looking for. So these are the outputs here. This output from SPSS, all what I did is to save it as SPSS, but I also like to keep it as PDF because I'm not sure. Anytime you might lose your trial will be denied. So this way you can print it as a PDF and then you can keep it, all right? This is what I've done. And now I got all the results for you. Oh no, this is what I don't like about it. It's kind of like cut into two. I should have done a little bit of formatting. All right. But I think for the Cronbach alpha, everything is all right. So, oh my goodness. Here. So this is reliability. I forgot to name the scale. So over here, informative value is, as you can see, 0.7. So you can just put over here. I think you know what I mean. So informative value and 0.7 something. What was it? Informative value. 753. So you just put that in there. 0.753. So please complete this so that we can put it in your paper. And look at this beauty, 0.74 informative value without info 1. So I was thinking, what if we drop info 1? Because info 1 was the only factor that doesn't have double loading. It's loading somewhere else totally completely, and it has zero loading in informative value. So for this purpose, I just wanted to make sure that everything is all right. So yeah, everything is still all right. And even if it's a little bit less than all right, I would just around 0.7, even if it's 0.69, I would still accept it. But this is not bad. This is awesome. And over here, 0.788 for entertainment. For brand fit, it was very high, 0.89, almost 0.9. Expert, so very good job, Anna, because this is something of your own contribution. You added to the theory. Awesome job. Expertise is 0.89. Awesome. Trustworthiness is 0.94. Oh my God. And then attractiveness is 0.775, very high. Similarity is 0.843. And credibility, even though we didn't use credibility in my explanatory factor analysis, but here credibility is also 0.863. And then parasocial is 0.84. And then purchase intention, the most important one, is 0.875. Now, what is it that I need you to do for us? What I want you to do is to basically run, because I want to make sure that you also do some work. I would like you to run dimension reduction for everything, including a credibility. I remember I've done it with you. I want you to add the credibility here and hit OK and take a look. The total variance explained is now 71. It is less. It was 72, I believe. I shouldn't believe anything. I should have it written here, but I forgot to write it here, huh? Okay. Anyway, yeah, it would be nice to just document everything. So I would like you to just take a look with the credibility here. This is the pattern matrix, the same behavior for info 1 and info 5, same thing. And entertainment value here, I don't remember having entertainment value loading into info. Let's take a look here. Now we can compare, huh? Oh yeah, here, entertainment was not loading into info before. You see that? Entertainment was not loading into info before. Fit is cool, and expertise is very awesome. Here is 0.9, here's minus. Okay, no problem. But it's not because it's minus, it's still 0.3, yeah? It's just the inverse relationship here. Expertise and what? Expertise and similarity, okay. Trust is good, but still have the same observations as before, multiple loadings here and there. Credibility here, it's very kind of weird that the first question is loading higher on brand fit and the second one, and then you have credibility here, and then you have credibility here negative with entertainment. Okay, and then this is clean cut, attractiveness, same observation, and over here same observation, parasocial, and here you have two loadings. Previously I had two loadings in parasocial 6, if I remember correctly. I had two loadings actually in parasocial 1. Let's take a look. Parasocial 1, does it have two loadings? Two double loadings? No, it has only one double loading, and the double loading is here with similarity still. So it's the same problematic situation. It's just that you have a big problem here with the credibility 1. What is the cred 1? Cred 1 is, I also have it here like that in the Excel sheet. I don't have it here. Okay. I have it here though. We shouldn't have been asking questions for credibility anyway, but oh, I didn't add it here. I gotta add it here. So credibility 1. Have confidence. Okay. Anyway, I think this is something Saima Khan. Okay. So we still have a source for it, a very new source for it, but still wasn't, we added our own here, right? Our own were better than the one that we got from the literature. It's the kind of situation that really sound a bit funny. So over here we have, So we have here the credibility. I'm just going to add them. Okay, so now I would like you to do the same thing that I've done with the factors without credibility, and it's up to you. I mean, it's not a matter of it's up to you. There's two ways to approach this situation. There's something called path analysis, right? In SEM. With path analysis, we could use all these underlying factors here. So as you are studying right now, as you are doing the analysis, I would like you to study more and more. So as you are studying, you will find out that with path analysis, with SEM, we could use all these guys to impute, we call it, impute values for credibility. So we don't necessarily need these guys, but it's okay. I think it's good to have these questions. So we might end up resorting to using these questions for credibility rather than complicating the model. So basically what I want you to do, please, to redo my analysis and put the results here in pattern matrix with credibility and copy the same exact style. So I would like to know which ones are problematic, and we try to here very easily, we try to refer to this Excel sheet and understand which questions and what was the content of the questions immediately in a one-stop shop. But here you are going to add credibility. I believe you can produce these results, but if you can't, Daijobu, I'm going to save this for you just in case. Also, KMO is good. So I'm going to keep this for you, all right? I'm going to just right click and copy. And over here, just paste it. And now you can do the analysis as you like. And this one has credibility, all right? Okay, I'm going to save it here. Just in case you haven't installed the SPSS yet, the trial. And here, I'm going to just do one little thing very quickly, even though I've done it before, which is the reliability of the credibility, because I just want to make sure here we have it all together. So over here we have the results of 0.863, right? So this you can save it as exploratory factor analysis with a credibility, and you can also save it as a PDF. I like doing that because I'm not sure when I will lose my access for the trial. I hope I won't, but in any case I'll have to buy it. With credibility, maybe so that in the future you can come back to see the KMO value, for example, and so on. All right, Anna, take care of yourself and good luck with your research.